Good afternoon, everybody. Fusion Phil over here with jitcadcam. As you guys have noticed, we've started to release these FeatureCAM videos. You guys want to know, no, I'm not rebranding myself as FeatureCAM Phil. We have several people for that on this team. That said, if you guys like what you're about to see with the turn mill, B-axis, as well as simulation, go ahead and give us a like and a subscribe as well. Leave us a comment for any content you want to see. As well, if you have something in particular you need help with training-wise or support, shoot us an email with that info down below. Let's get to the content.
Welcome back. We're going to look at turn mill in these next couple videos that we're going to do with this part. However, I'm going to focus on a few more turn items that are additional to just the standard turning stuff, namely B-axis. And we're also going to look at machine sim and a transfer after we do the cutoff as well. So these are going to be in addition to that. So I want to cover these. This video won't be super long. So let's take a look at what I'm talking about. So here's the part we have set up on the main right here. We have the setup on the subspindle, so the other side. Okay, so we're going to do the turning and stuff on here. So let's just do a quick little simulation through here. Okay, so we got this. You'll notice that I have a different shape tool. I have a 35-degree tool. That tool is vertical. And it's doing the turn stuff, and it's going to go down in after it gets this first part right down in here. It's going to go into this area, and we're going to machine that. Okay, but if we look closely at our part, there's actually an undercut in here. So with that tool being vertical, I'm unable to reach up under there. So let's just go ahead and run the full simulation of what I have already created, and then we'll see what I'm talking about. So you can see that we can't really reach up under there. And you notice this tool right here was tilted. Okay, so that may have happened really fast. So we'll go with that. But before we do that, let's just look at our results so we can kind of see the part. So I won't be doing any of the milling on this, but I will be talking about B-axis and machine sim, and then we'll do turn mill in the next series video. Okay, so we have a few milling features on here just to kind of get familiar with this as well. Okay. All right, so what I want to do is look at B-axis to start. Okay, so B-axis, I have another example file. This part right here has 3 simple toolpaths on it. This is a turn with a vertical tool. And what that means is in the feature, when you have a machine that has B-axis capabilities, then you'll have the B-axis options in a couple spots in FeatureCAM. On the roughing, it's right here just above the tools. And so this is just going to be a regular Southwest tool locked. You know, you could put it in a turret and it would go. So if I preview that, we can see the tool stays vertical. Right there, we've violated the part because we have kind of an undercut on the front of this, almost similar to what we have on the other part. Okay, so we'll go here. So we want to maybe tilt that and maybe even use a different tool. Okay, so that's what the next one is. So if we look at that, let's see what it does, and I'll show you how it was controlled. So you can see this tool is a little bit different. It's tilting to reach up under there, but we also have a fixed angle set, and so what you see is that we're violating the part there. So we might need to do something called B-axis simultaneous on a part like this. But let's look at the B-axis control on this toolpath. So it's set to B-axis and set to neutral. That's how you get it in 45. So if I go back to OD turning tool, that's like that. Switch it to neutral. It's vertical when it's at 90. We can go 45 or whatever angle we want. You can even rotate the tool around if you want. Okay. All right, so that's that one. So let's see the other option we have here. Let's run the simulation on it first. And you'll see this is actually even another tool just to kind of give you a little variation. And you'll see that this does some tilting, and you can see there's a little violation there. You see it's allowed to go vertical, and it's tilting along the way. So that happens on the finish passes. All right, so if we set this to a lead angle of 20 and watch this, you can see that opens it up and it's really just kind of all over the place, right? So it's able to tilt 20 degrees. It's almost like lead and lean in a surface mill. So it would be like lead on that. So we're saying we want a 20-degree tilt, but it's basically 20 degrees from the normal, like perpendicular to the part of the curve you're on. So we need to limit it. And you saw earlier that it was, violating the part a little bit, somewhat. So I can give it a different range, say 70 to 90. So it's trying to maintain that 20 degrees, but I'm only allowing it to tilt 70 to 90. And you can see it went back vertical. And right at the beginning, that's where we're getting it. So I might need to change that. That would be the 90 value. So maybe we go 60 and like 80, something like that. So we run that, get the tilt, we get the simultaneous motion, and controlled that way. Okay, so back, now that we understand kind of the B-axis, let's go back to this part. So on this turn feature right here, that's the one on the main. You can see that I need to go to the B-axis, and I want to set a neutral, and I'm going to set a fixed amount, and I'm going to go like 70 degrees. All right, on the finish pass, we're not using simultaneous because this shape doesn't really require that, and I've also got that set to neutral and 70, and you see the B-axis stuff I have turned off. Okay, so let's go ahead and run through this. Run the facing. All right, go back to the top view. All right, so we got the facing and then the tools tilting to do the roughing. And so we'll go ahead and just run this and we'll see how we can reach up underneath there now. Okay, and I've got a depth of cut that's not having it pick that out. So if I change the depth of cut, we'll reach in there a little more. So you see the finish pass is getting up under there and cutting that out. All right, so there's just that little bit of an undercut there. So just as a reminder, your depth of cut, you can set in your attributes or your configuration for your attributes and adjust, but I'll just adjust this toolpath just to kind of show you. We'll preview both of these. Remember, the preview mode is really handy. So you can see just the toolpath, and on this case, I want to see both. You can see how the tool is able to reach up under there now. Okay, so get out of preview, and let's take a look at some more of this. So one more time, let's run the 3D and see what we have. So there's the tilted tool. We're able to get up under there and reach in and get that undercut using the B-axis tilt. We got a cutoff, and we have some sub work. All right, so what we want to do now is talk about the machine sim. Okay, so right here I have the option to do machine simulation, and depending on what machine you have loaded is what you're going to see. So there's what's called a machine design file that can be modified using solids from the manufacturer. There are a lot of them Autodesk already has, so we can get those to you. But this is a stripped down version of like a Morisiki, like an NT4250 or something. There's that machine. I'll show you another example like a Kuma Multus. And you can see we got this has got a little more going on with it. You can have the doors and all that, as much detail as you want. These are purposely been stripped down a little bit just to, because what you really need to see the doors in simulation. Heck, you don't even like the doors when you're trying to watch your machine when you're really running it. Okay, so we're definitely not going to have them here. So we can see this, and what you'll see is a transfer happen and a cutoff, and we went over to this side. Now, I'm going to hit right here because this machine's not quite big enough. I have the gouge checking turned off right now, but I just wanted you to see this completed part. Just kind of get an idea, and I'll switch back to that little bit larger work area machine that I had before. It was stripped down even more. I switched the post out. The machine associated with that is now loaded. Okay, so let's watch this. You'll see there's nothing on, this has got a lower turret where the other one was just B-axis, right? So I want to put some of the tools on there. So I'm also going to show that in this video. Okay, so really more turning and the synchronization and things like that. So we've got a completed part on both sides. I'm able to grab it. I want to put some stuff on the lower turret as well. Okay, so the way we deal with doing that is in what we call the tool post tab, and that's actually right here at the bottom right of the software. Okay, now before I get into synchronization, so there's a couple views here. There's a time view and an operation view where we can synchronize. Those are important, so we'll be looking at those, but I need to finish telling you about the cutoff and how I did the transfer. So when I did the cutoff in the previous video, we didn't do a transfer. Here, however, we are doing a transfer. So I have some transfer parameters set up in here. Okay, so when you first open this will default to 1 inch for the grab distance and 1.25 inches for the feed distance. Okay, so those are important. So kind of see a little bit of the F and the G here on this little sketch. But basically, this is how much from your setup 0 do you want to grab of the part. I don't have a ton on this part to grab. I have like 900 thousandths back to this wall. So obviously, you need a little bit to grab onto, right? Anyway, so I said, okay, 875. And then this feed distance is essentially from where you're going to end up with the grab. So in this case, 875 down from 0, we're going to grab the part. From that distance, how far away do I want to stop rapid motion and start my feed motion down to complete that grab? So that number is typically a little bit larger than this because you're going to say, hey, I want to stop rapid motion, start feeding down. So this would be essentially an 1/8 of an inch before 0 because we're going to grab 875, but we're saying, hey, 1 inch from that, start the feed motion, right? So we'd be just above the part. Now you'll see some sort of math going on down in here. Now you don't have to type the parentheses and all this stuff. FeatureCAM did that for me when I completed this. So you'll see 8 plus 2 plus 250 plus 20 thou. Hopefully you can see that okay. So 20 thou and then the 8 plus the 8.2 plus the 250. All right, so the 8.2 is the location of my cutoff. Okay, so we need, if we're going to do the cutoff and pull it out enough to be able to have the next part ready, we got to pull it that 8.2 plus the width of my cutoff tool, is 250, plus on my facing, I have 20 thou that I'm taking off, right? So for the next part, we're trying to get it in position. So we're going to go the cutoff cutoff location, exclude the negative value. You don't need that here. So we want to pull it a total of 8.2 for the cutoff plus the 250 of the tool plus the 20 we want to face off on the next part. So that's really as simple as it is. You check it, put in your numbers. So you can just copy and paste this, copy and paste that, and then knowing what's on the next part, put that in. Really simple. Okay, so that'll allow it to do the pull. All right, now let's talk about synchronization here. We see a time right here. When I go to the tool post tab, we have a time view and it's 8 minutes, 18.8 seconds. If you look at this, we've got the B-axis head and a turret. So that's main spindle work. This is sub spindle work. And each of these have a little bar associated to it. And the longer the bar in this view, the longer that toolpath cycle is taking. So I can scroll my wheel on my mouse and zoom way in, and I can hover over like the first operation And it says, if you read the little pop-up there, starts at 0, beginning of the part basically, and runs for 18.3 seconds with those values. And then this one starts at 18.3 and runs for 4 minutes 54.9 seconds. So we get a really long bar. I'll go ahead and roll the wheel back out. And you can slide this over. So if you zoom way in, you can slide this over and see all these operations and see when they start, how long they run. You know, there's other operations tucked in here, right? So we got our poll and all that stuff. All right, so that's one way. And then of course we can see on here, that starts at 6 minutes, 12.7 seconds and runs for 20.3 seconds. And so that's how it comes up with this time. All right, now I want to reduce this. So we got a baseline, 8 minutes, 18 seconds. So if we remember that, that will be good, right? So make a little note. All right, what I want to do is have FeatureCAM doing work on both the main spindle and the sub spindle. So the B-axis head can work on either one. The turret can also work on either one. I'll keep this one kind of simple. I'll let the B-axis head do the bulk of the work or all the work on the main setup and maybe have the lower turret be working at the same time on the sub spindle. So what I can do is start figuring out which operations I want to move. So we'll go with the facing, the turning, and then there's a groove. This little V area is a groove that I'm using a groove feature to get that area out. I'm going to take those and I'm just going to drag them over. Now, if I drag them here, they'll be below the cutoff and stuff. I want them to be up above. So you can see I can just simply drag and drop. Okay, so colors mean things too. Blue is the main spindle, so you can see the spindle icon, and orange is the sub spindle work. So you can do either one. If your machine can reach either side, that's fine. So here's an example of where I'm going to leave something that's happening on the sub spindle. I'm going to let the B-axis head. I'll let the twist drill before the boring operations. I'll let that happen using the B-axis head. I also want these to move over. So you see how I'm just moving them just above. The cutoff should always be at the end. This is automatically synchronized. You don't have to do anything here. FeatureCAM will just automatically synchronize it. These red bars are basically synchronization points for weight codes, things like that. All right, so let me show you what I need to do here. So if I try to run this right now, I would probably have some, if I'm trying to do the drilling while I'm working on one of these other operations, that could be a problem, right? Now on this part, the main spindle is going to be taking a bunch of time. We know this rough pass takes quite a while, right? That was like almost 5 minutes if I remember. So what I want to do is while the facing and the turning is happening on the main spindle, I'm going to go ahead and allow those, the face and the turn, because I'm turning this little portion right here on the sub spindle. Just getting what this is. So the groove gets this, and then the turn gets this up over this little radius just a little bit. So I'm using a boundary to contain that. So I'm using the same curve for both the main and the sub turning work, but I'm using the boundaries that we talked about. So I'll show you those before I get out, because I'm going to need to do one more feature right here and just kind of show you how this works. Okay, so let's get the synchronization sorted. So we want these two to run at the same time, and let's go ahead and have these run. So as long as they're not going to collide, I don't have to do anything, okay? But I'm going to have the B-axis head do this drill before the bore. All right, so what I need to do is set this. I choose the one I want to run first, and then I grab the one I want to run after. I'm introducing basically a weight code. And I'm going to hover over this. You see these icons right here. These are your synchronization buttons. It says set sync for the bore pre-drill twist drill before the bore on the sub rough pass, right? So when I do that, you see I get a bar across here, and this is going to run before this. Now, if I want two things to run together, I can synchronize them at the same time. So I could maybe do these two rough passes together. I don't need to here. That's actually going to add time, but I just want you to see how that works. So this one, you see that it put the operation below, because you can see that kind of this before, that after, right? And then this one is run at the same time. So we don't really need that. So you can remove sync points just by hovering over it, right-clicking, doing all that. Let's see what we got here. So this isn't a really complicated part to synchronize, right? So once we get a little more going on this part in the next video, we may need to do more. So now you see we've got work happening on both sides. Got a really long boring bar. Probably should change that. But you see right here, we're at this point where the roughing is still running and all this stuff is done. So it waited to do the bore until this drilled. Okay, so that happened real fast. So let's run through it one more time. Okay, I'll go a little bit faster, but I'm going to kind of control the simulation. I'll let the sim run a little faster, but I'll run through here and just do next operation, and then maybe just do single step. Okay, so we got that. It's doing the roughing. So you see the lower turret's waiting because of this right here, and you're like, oh man, maybe we could just put the drill over here on the lower turret and be done. Likely we could, but we want to just kind of see how synchronization works. All right, here we go. So this is drill, looks like an end mill. That's actually an inserted drill, or yeah, inserted drill. So that's why it's got the flat bottom, because my part has that. So you see it's just kind of previewing through here because I haven't done the transfer and all that stuff yet, right? Okay, so but you see the motion. All right, so let's watch this in full machine simulation. Okay. So the first time through, it's empty. That's why we were seeing the motion. So you can see that this is happening really fast, I know. I'll go ahead and zoom in on this so you can rotate around. Now, just so you know, if you want to, if you have a little more complicated machine design, you can actually hide components. So if I hit the select arrow at the top, I can actually hide this cabinet, I could hide doors, I could hide any of those, and in order to get those back, I can hit show all and bring them back. But we know this machine's got some, it's not quite big enough for what we're trying to do here, so we're going to go ahead and go with this little bit bigger work envelope machine that's been stripped down. Okay, so see the tools, see our boring bar, you know, so we see all that, and the important thing is we want to look at the look at the time view. So when we did synchronization, that updated. So we were at 8 minutes 18 seconds, and now we're down to 7 minutes 14.7. So when you do synchronization, you can see the updated time, which is super helpful, and you can see any collisions that you might have. Machine Sim will show you collisions as well. Just make sure you have that turned on, and we have this. Okay, so the boundaries, I talked to you guys about boundaries a few minutes ago on the turning. So just as a reminder, when you go to the turn or bore feature, you can set a boundary, and you remember the undercut setting in the previous video. If I were to turn that off, then the tool wouldn't go down in here at all, right? And I would have to figure out something else. Plus, I wouldn't get that little undercut in this area. So I want this to actually adjust and use the B-axis to help me out. So you can see all that it machined. We have this left. Then the spindle side boundary I have set to basically back here. So just kind of over this radius on my part. And then you can see we're getting down in there. So if I adjust that a little further, you know, we might reach in here a little more, but you can see we're getting in there pretty close anyway. It looks like we're good. So that works. And then on the sub spindle, I did the same thing. And I have just a rough pass. Now it shows the turret in the lower turret. It's upside down because I moved it, so it just automatically does that. Here's the machining area that it's doing, because remember I have a groove feature that's taking care of this. So I'm just basically blending this radius. Okay, so I got it set there, and that's where we want to end up basically. And so We're staying out, so I do have the undercuts removed here, and then just set a boundary on the spindle side. All right. Okay, so let's do a turn feature to get this last little bit. So I'm going to go in here, do turning. Turn from curve. I've already selected the curve. It's there. We see the feature that we're getting with turn and turning cycle. We've got rough pass and finish pass. We know we need to kind of get this last little bit. So we'll go ahead and do that. So it's really kind of in here, right, that we weren't able to get. So we'd have to look at the other one to know that. But I'm going to just set my boundaries anyway. I'm going to hit finish right here. It's going to grab an 80-degree tool because that's just what turn does. We may change that, but let's look at our machining boundary first. So this is going to be towards the spindle side. So our part is set. Let's just pan this over a little bit. Our part is set with this as the sub spindle. So that's the spindle side. So what we're going to do is set a boundary on the spindle side and basically just kind of right there. We see the boundary update accordingly. Okay. Then we also don't need to machine all of this. So I might set the maximum radius. Same thing, just kind of snap onto that. See that adjusts it there. And then we want to get the spindle on the face side and maybe just kind of eyeball it here, and we see our boundary updates. And if I preview that, then we get the machining, roughing it out, and then of course the finish pass. And we don't really need the B-axis on this one, so we'll let it do its thing, but maybe we want to do that. So we'll rough it out vertically. So just as a reminder, there's the B-axis button. We'll do OD and the finish pass. Maybe I'll tilt that a little bit. I'll say neutral and do like 80 degrees. So in this case, since we're going the opposite, we're going basically the other direction, we would want like 100, right? So vertical is 90. All right, so that's how that works. And then I could go over and do my synchronization. So that added time, go to the operation view and do my synchronization again, right? So I reset all these before I did that feature. So just one more time, let's do the synchronization. So put those over there, drag and drop, right? We want to do the groove as well. Put that just up above that cutoff. And then we want the pre-drill up here. And we want these two tool paths to run as well. So maybe we'll save the boring feature for last, right? So we want to say, let's run this before this. Clicking there, okay, and we get our synchronization point. Okay, so that wraps it up, and that's turn mill with the machine simulation and also B-axis. Thanks for joining me. We'll do the milling features in the next video.
And that wraps up yet again another FeatureCAM video. And as we always say, it's not what you know, it's who you know. And you all know us, jitcadcam over here. We're here to support you in any way possible. So don't forget to like and subscribe as well. If you have any other questions or any other issues with FeatureCAM, feel free to shoot us a message with the email down below. Thanks. Have a great rest of your day.